So the reason that we look at squares and square roots is because we want to look at the Pythagorean relationship. And the Pythagorean relationship is for right triangles. So here I have a right triangle, and the relationship is that the square areas from the sides are related. Okay, and we often want to either start with side length or we want to find the side length. So we need to be able to do squares and square roots. But the relationship is about the three squares here. So when I look at this relationship, I have the longest side, which is called the hypotenuse. The square area from the longest side is going to be the biggest square. And if I draw squares from the two shorter sides, which we call the legs, these two areas here, always add up to the larger area. Okay, so that's the relationship. And we can find the side lengths through that relationship. So looking at this diagram here, we want to be able to relate these three areas together. So I need to find the area here. Okay, so if the side length is 6 units, if I square, I can get the area. So I'm going to square the side length to get a squared, and I'm going to get 36 units squared. So in this space here, I get 36 units squared. Since I have two areas, I can find the third area because I know that these two smaller areas from the legs add up to the area from the hypotenuse. So if I want to find out the smaller square, I can subtract these two areas, and I'm going to end up with 19 squares in that. So b squared in this case is going to be 19 squares. Okay. But again, we often want to find out the side length. So if I want to find the side length, I need to square root. So if I want to find the side length from the hypotenuse, I take c squared and I square root it to get c. So I do square root c squared, and then that gives me a value of c of 7.416, which I'll round to 42. So if I want to find the side length, I could either get exactly square root 55. So although I see the area, the square root indicates it's a side length, and that side length is approximately 7.42. If I want to find the side length of b, okay, so I'm just going to write this in here, 7.42. If I want to find the side length of b, I can do exactly square root 19. So although I see the area 19, the square root indicates it's a side length. And if I want the decimal value for that, square root 19 is approximately 4.358, so I'm going to round that to 36. So that's about 4.36. Okay, so I can find the length of these sides through the square area relationship. And that relationship is a squared plus b squared equals the bigger square c squared. So we can do the same thing here. So I have my biggest square is 144 squares. I've got another square here is 64 squares. That allows me to find the square area off this side here. So if I subtract these, because I know that the biggest area, I have to subtract from the biggest area, I end up with 80 squares in this square here. Okay. So a squared in this case represents 80 squares. Okay. Now, I often want to know the side length, so I need to square root. So if I square root 144, I get exactly 12. If I square root 64, okay, I'm going to get exactly, so b squared is 64, I'm going to get exactly 8. And if I square root, so I'm just going to write that in, if I square root 80, that's going to be my a. So I can show it exactly as square root 80, or I can give it approximate decimal as 8.944. So I'm going to leave that as 8.94. So that length is just a little bit longer than that length there, and it should be because this square is a little bit bigger than this square here. And just a reminder that be careful because sometimes we subtract from the bigger square, or sometimes we add the two smaller squares. Okay, but it's always the two smaller squares add to the big square. We never add the big square with another square.